Hello, everyone. Today we'll cover MCP, the Model Context Protocol, a standard that connects AI agents to external tools in a uniform way. The big idea is simple. Like USB-C for devices, MCP is a common connector for AI and tools. Let's anchor the concept first. MCP is an open standard interface. It's not tied to a single vendor or model, and it lets AI talk to tools and data sources using the same grammar. The practical benefits are extensibility and interoperability, and most importantly, reusability across models and environments. Why do we need it? Historically, every tool integration was bespoke, leading to complexity and maintenance overhead. MCP standardizes request, response shapes, and tool metadata, eliminating repetitive glue code. The result is faster development, easier maintenance, and smoother feature expansion. Picture the architecture verbally. The AI model sits in front, MCP in the middle, and multiple tools behind it: web search, code execution, databases, APIs, file systems. Inside MCP, you'll find standardized messages, tool metadata, and context management, so the model understands a tool's capabilities and limits. In short, a clean three-layer stack: model, MCP, tools. Here's how it works. First, request shaping. The model's intent is wrapped into a standard message. Second, tool execution. The right tool does the job. Third, standardized response. Results come back in a consistent schema. Fourth, context integration. Outputs are safely merged into the model's working context for better follow-ups. A crucial piece is tool metadata. Each tool self-describes its functions, inputs, outputs, and constraints. The model reads that description and calls tools correctly. In practice, metadata acts as both documentation and contract. Let's scan real scenarios. Intelligent assistants unify calendar, email, and search under one protocol. Coding copilots orchestrate execution, debugging, and version control through consistent calls. Data analytics chains DB queries, visualization, and statistics into a clean pipeline. In the enterprise, you can wire CRM, ERP, and HR systems to build an AI workplace assistant. The payoffs boil down to four: developer efficiency, expanded AI capability, better user experience, and a healthier ecosystem. With a standard in place, adding a new tool often becomes register metadata and go. Cross-team collaboration also gets much easier. Compared with ad hoc integrations, standardization and reuse are the defining advantages. Instead of rebuilding connectors for each model or stack, you implement once and reuse widely. That's a decisive win in scalability and interoperability. Keep these implementation cautions in mind. Security and access control come first. Scope tokens, audit logs, and clear data boundaries. Error and timeout handling demands recovery strategies and defined fallbacks. Versioning should plan for backward compatibility in protocol and tool schemas. For performance, minimize context, batch calls, and use caching. Finally, embed a user feedback loop to continuously improve tool selection and response quality. A quick practical example: suppose you need complaint intake, CRM lookup, ticket creation, Slack alert. With MCP, define each step as an independent tool. The model reads metadata and chains calls in the right order. On failure, it can shift to fallback paths, like CRM lookup failed, query cache, create minimal ticket, standardized at the task level. To wrap up, MCP is the common standard for AI tool integration. It makes connections simpler, operations lighter, and feature growth faster. Keep four pillars in mind: standard interfaces, metadata-driven self-description, safe context integration, and the triad of security, versioning, performance. Nail these, and your AI products become faster, safer, and more flexible. Final keywords for recall: model context protocol, tool integration, open standard, interoperability, context management, reusability, security and access, error recovery, version compatibility, performance optimization. With these, you're ready to apply MCP in the real world.